Graphs of sine and cosine functions. The sine and cosine functions are basic trigonometric functions that have special parent function graphs. Now, the basic sine curve is one of the first ones we look at, and what that's going to look like is it's going to go through the origin here. It's going to come up, it's going to curve back down, and it's going to start going back up, and it's going to look the same on the other side. So it's going to go down and up and start going back down, and then it just keeps on oscillating back and forth like that. So the key things that we're going to want to note are where are the points that's crossing the axis. So right there is 1, and right there is -1. So what that means is that our range is from -1 up to 1, including those, and that's going to be our parent function range. Our domain, it goes on forever in both directions, so it's going to be -infinity to +infinity. Now the period is just talking about how many times does it go back and forth until it repeats, and that will go to pi distance before it repeats. Okay, and now we want to graph our x-intercepts, because this is going to be the tricky part. Our y-intercept is obviously the origin, 0, 0. Now our x-intercepts are right there, right there, right there, and then they're going to continue on. So we want to generalize this type of intercept. So the first one is 0, 0 right there, and then it goes up by pi over 2. That's the thing to remember, is it always goes up by pi over 2, which is 90 degrees, if you want to think of it in degrees. So that's pi over 2, pi, and then 3 pi over 2. And then it goes back the other direction. So we have -pi over 2, -pi, and -3 pi over 2. So it goes the same in both directions. So to generalize our x-intercepts, we would just take any number, however many far we want to go down the line, times pi, and that's what crosses the intercepts, because we can see it's always going to cross at a pi somewhere. And our y is 0. Okay, now a couple other things to note is this is an odd function, which we've actually already talked about in a sense that sine of -θ equals -sine of θ. That just means it's an odd function. And it's got origin symmetry. That just means that the symmetry is in relation to the origin. So if you spin the graph around the origin, you would land on top of itself. Okay, so this is the basic sine curve. The basic cosine curve is the same in many ways, except it's not going to start through the origin. It's going to start up here and then curve down and up and then down and up on the other direction. And then it's going to oscillate back and forth that way. In this one, it's going to still have a domain of -infinity to +infinity, because it still goes both directions forever. And the range is still going to be -1 to +1. And the period is still going to go 2 pi before it repeats. So the period, the range, and the domain are the same of these two parent functions. The intercepts are going to be what changes. The y-intercept, we can see right away that it's at 0, 1. So that's the difference. Basically, it's just been shifted a little bit. So instead of crossing at the pi's, it's going to cross at the pi over 2. So here's pi over 2, and this is -pi over 2. And then the pi's are when it's on its peaks and valleys. So that's going to be pi and -pi, and there's 3 pi over 2, and -3 pi over 2. So it's just been shifted pi over 2. So how we're going to understand what that looks like is to find our general x-intercept points it's going to be pi over 2 plus whatever our n pi is. All we've done is shifted it pi over 2 and 0. And what we want to note about this function is it is an even function. And that's proved by cosine of negative theta equals cosine of theta. So that's why it's an even function. And it has y-axis symmetry. What that means is if you flip it over the y-axis, it's going to land right on top of itself. That's the whole idea. So we're going to do some examples of graphing these basic sine and cosine functions. If we have f of x equals 2 sine of x plus pi, okay, so we got to remember our transformations here. First, we want to start by graphing our parent function. So it's a sine function. So the parent function is sine of x. So I know it's going to go through my origin, and it's going to come up here, and it's going to cross at the pi's. Alright, so then I'm going to just connect my points here. So there's my parent function. Now I need to figure out how it's moving. Well, the first thing that it's doing, it is vertically stretching by 2. Because that's multiplied by 2 on the outside. Okay, so I'm going to start by just multiplying everything by 2. So everything's going to go down to 2 or negative 2. The peaks and valleys. That's what we're looking at. It's still going to cross at the same places because 0 times 2 is still 0. So that's going to be after my vertical stretch of 2. Alright, now the last part is plus pi. It is inside with the x, so that means it is a translation either left or right, and because it's plus pi, technically it's left pi units. Okay, so if I'm going to take this point right here, I'm going to move it left pi. And then I'm going to take this point right here, I'm going to move it left pi. And everything's just going to move left pi units. So what that's going to look like is it's going to be down here and come up and through, and then it's going to cross up here and go down and up and down, and then it's going to keep on doing that. Back and forth. So all we've done is basically we've shifted our valleys, or if we're looking at the green one, our valleys are now our peaks, and our peaks are now our valleys. So basically this has kind of just been flipped over the x-axis. That's all that's really happened here. So that blue one is your final function. For this next one, the first thing we want to recognize is our parent function. Our parent function is cosine of x. So I'm going to graph that. So our parent function will cross at 0, 1, and it will cross at my pi over 2's. And our peaks and valleys will be at the pi's. So that is my parent function. Alright, now I need to recognize what is changing. The first thing we should see is the negative outside, so we're going to reflect over the x-axis. So that means is everything's just going to flip over. So again, our valleys will become our peaks, and our peaks will become our valleys. But they're going to cross at the same places on the x-axis. The next thing we need to do is translate it right pi over 2. So when we do that, what we're going to do is actually just shift all of these green points over pi over 2. So that would be the basic idea with that one. But that's not the last step that we have. Last thing we have to do is the plus 1. So that would be a translation up 1. So when I translate the blue function up 1, everything's just going to shift up 1. So that's going to be what your final function looks like, more or less, that yellow function. So just as when you're trying to graph any type of graph, it's sometimes easier to start with your parent function and then shift it around based on your translations, just like we did before. So those are your notes over graphing sine and cosine functions. You should go through the few practice problems of these and make sure you're comfortable graphing these functions by hand.